All right, number 11 here kind of sets the stage right here, telling you that these two diffie-q's appear similar, but tells us they have very different solutions. So basically, they're getting a 2-for-1 here, guys. They want you to solve two differential equations in one problem here, but both subject to this initial condition here, y of 0 is equal to 1. So let's get working on each one. On the left here in blue, I've got the first one, dy dx is equal to x squared. Separating the variables, all we have to do is bring the dx to the other side here, and we'll get dy is equal to an x squared dx, and that's it as far as separation goes. So now I'll anti-differentiate the left and the right. Antiderivative of dy is just a y, and that right side is now going to become a 1/3 x cubed plus c. At this point right here, I like to switch colors to green here and solve for c. So when x is 0, y is going to equal 1. 1 equals then, 1/3 times 0 cubed is just 0 plus c, so there it is, guys. C equals 1. And, this was kind of nice, that equation there was already solved for y. So I think once I write this, we're good. Y is equal to a 1/3 x cubed and a plus 1 at the end. So that is, everybody, the only function that exists that has this derivative and passes through this ordered pair of 0, 1. So that one wasn't very hard to solve, but I got a funny feeling that what's happening on the right is going to be quite a bit harder. Okay, now to separate our variables, we have to divide both sides by that y squared to bring the y to the left. Remember, guys, what you don't ever want to do is something like this, even though it seems easy. Dy dx minus y squared is equal to 0. You never want to use addition or subtraction to move terms around when you're solving a differential equation. You always want to use multiplication and division. The issue here now, guys, you can't really get rid of the dx without putting a dx on this term as well, which kind of defeats the purpose. So here we go. What are we going to do instead? We are going to, as I said, divide both sides by y squared, okay, or multiply by 1 over that. And to move the dx, we'll multiply a dx in each numerator. So this cancels with this. The dx's on the left are gone, and the y squareds on the right are gone. So that should leave us with, not great, a 1 over y squared, squared, dy is equal to, and then all we have on the right is a dx, so I guess that's that. Okay, we have separated our variables. Let's try to anti-differentiate both sides. Now remember, guys, 1 over y squared should probably be thought of as y to the negative second. So when we go to anti-differentiate that, we take our y, we raise our power by 1, which is now negative 1, and divide by that new exponent, which puts a negative out in front of that. And this equals, the antiderivative of 1 dx is just x, but of course we need to add a c at the end of all that. So again now, I want to switch back to green. I want to use my initial condition here. When x is 1, y should be 0. Strike that. When x is 0, that didn't sound right when I said it. When x is 0, y should equal 1. Okay, so putting a 1 to any power is going to be 1, and the opposite of that makes a negative 1, and then that equals an x value of 0 plus c, so kind of like last time, solving for c was pretty easy. C is negative 1. Okay, so let me go back to where I was a moment ago, and back right down here, guys. We now have the opposite of y to the negative first power, and that equals an x and a minus 1, since we now know that c was negative 1. First thing I would have to do here, guys, is take the opposite of both sides of this equation. Effectively, I'm dividing both sides here by negative 1. That's going to give us a positive y to the negative first power, and that would become a negative x plus 1, or better yet, I think a 1 minus x would be the simpler way to write that. And now, this is something that bothers people sometimes, simply because we don't do it very often. How do I get rid of a negative first power? Well, what I want to remind you guys here is that a negative first power is a reciprocal. Y to the negative 1 is really a 1 over y. So what we're going to do then, guys, is simply reciprocate both sides of this equation. Now, the first part of this is easy then. The reciprocal of 1 over y is just y. But what people goof up sometimes, you cannot do a reciprocal term by term. It doesn't work that way. Real quickly, let me show you. 2 plus 3 equals 5. Hopefully everybody's comfortable with that fact. But if I reciprocate each individual term, 1/2 plus 1/3 equals 1/5? No. This is 3 over 6 plus 2 over 6. You end up with 5 over 6, which I'm no math major, guys. JK, yes I am. I'm pretty sure 5/6 is not equal to 1/5. So that's just a quick counterexample to show you that reciprocating term by term doesn't help. You have to reciprocate the entire right side of this equation. So it was 1 minus x over 1. Now when you reciprocate it, guys, easy peasy, it just becomes 1 over 1 minus x. You reciprocate the entire side of the equation there. And that, everybody, should be everything that we need in order to get this one to work out. Okay, so that's going to be our solution there for y in the second differential equation. And what they wanted you to see, though, is that while the two derivatives, the diffie-q's that were given to you originally, looked pretty similar, their answers really look very, very different from one another and aren't really related at all. So that's number 11 here, guys, just showing you that two problems that start similar might diverge pretty wildly and have very different solutions.